It's the guts of a early 2016 vintage Philips LED lamp, and it died recently, and it got pretty toasty inside. You can actually see on the outside of the casing there a bunch of cracks from the plastic degrading from the heat. By the way, this is how the heat sinking in these things works. There's actually an aluminum shell, probably stamped because things like metal spinning would be more expensive, that the plastic is molded over, and then what there is there's a really tight interference fit in that shell to an inner aluminum stamping which actually has the LEDs on it. Somewhat interesting construction. It's a flex rigid assembly, but it's actually a metal core printed circuit board where there's the mylar film that the copper is on top of, and then there's an aluminum pad under where each cluster of LEDs is. You can see this got really toasty for a long time because the solder mask is gone from much of it. It just turned into a white powder on the inside of the fuser globe, and the adhesives actually failed, and you can see that the mylar is coming loose. Also, the reason for the two different sizes of LED is that smaller one is a lower power, warmer white LED, because you can see it looks kind of hard to see on camera, but it's a little bit more orange. And what it is that LED is turned on as the lamp is dimmed, because this is a dimmable lamp. I don't know if, because obviously I can't test it now because it died, if the LEDs are all on and then that LED just stays on more as the thing's dimmed, or if that LED turns on as the lamp is dimmed and the other LEDs are turned off. Then onto the circuit board. Interesting thing to note with the adhesive failing is note how almost all of the components are just floppy and loose. That's because with this circuit board, the copper with the adhesive failing is actually no longer stuck to the circuit board substrate. You can also see the weave of the fiberglass. Like a lot of things that are built to a price, not a standard, this uses a hybrid material where it's a fiberglass layer on either side of a paper laminate, usually like a G10 or something similar core. Okay, so it has a certain degree of strength, but it's cheap. By the way, that discoloration right there is from the delaminating of the circuit board as it was getting pushed on in that direction, because that's the part of the circuit board that was where I had to kind of stab this hole to get this bit out of. But this is a very tight friction fit. That's because there's no thermal paste in there, and so that has to be the thermal coupling of this LED assembly to the shell. I mean, minimal heat sinking that it provides. And let's just say opening this thing up was a little bit of applied force and violence and smacking things with a screwdriver, so that's one of the reasons why all the components are loose. Now, interestingly enough, that capacitor hasn't vented, because ordinarily where that Y stamp is, that's a deliberate weak point, so if pressure builds up inside the capacitor, it'll bulge out there. Sometimes they can actually fail if the rubber plug where the wires enter the capacitor can. That's actually what that little dimple is right there, or that ridge. That's where the can is pressed down onto the rubber plug in the end. But, yeah. It got toasty, because ordinarily this circuit board material is much lighter in color, kind of like a tan, almost like a dark sand. And then this pin header in the end, that is what made the electrical connection to the flex rigid assembly there. Although, because it's failed from the heat, the plastic bit that held those contacts in place broke off. So yeah, this is a fairly spent lamp. Also, interesting thing to note because of its age, because a lot of the components were made in 2015, like week 50 of 2015 for the capacitor, the Ice Shore brand, which is very common in a lot of compact fluorescent lamps. It's cheap, but tolerable quality Chinesium. And of course, also 221 degree Fahrenheit rated. There's the transformer, week 23 of 2015. And where is it on the circuit? Yeah, see, 2015, September 7th on the board there. The thing to note with these is this aluminum is actually thicker than in a lot of modern lamps, because I've taken apart more recent lamps than this. Actual lamp was made January 2016. There's the focus you. There's a date code there, 6A, and then I don't know what the B is. And then that weird symbol next to the date code, that's the factory code. Don't know which factory that is, but there's a whole bunch of Philips factories, or Philips joint venture factories, I should say, making these lamps now, so finding information on it is not easy. This is kind of the start of the garbage, horribly complicated date code system they're using for a lot of LED lamps now. But, yeah, interesting. And even this, being a fairly cheap lamp, is still of somewhat higher quality than a lot of what you can get now, because it made it 7 years in service. Maybe close to 8 if I put this in 2016.